This video covers Lesson 2-3 of Secondary 1 Math, writing and graphing linear equations in two variables. Number 1. The restaurant in Seattle's Sky Needle rotates about 1.5 revolutions every hour. Let x represent the number of hours and y represent the number of revolutions the Sky Needle rotates in x hours. A. What is the slope? We can consider slope as the change in y over the change of x, which means that we're considering it the number of revolutions in the number of hours. And we learned above this 1.5 that it's 1.5 revolutions per hour. So our slope is 1.5. B. What is the y-intercept? Well, we have to think about this. If x is 0, we've done 0 hours of rotation, then how many rotations would have happened? Well, that would be 0 rotations if 0 hours or 0 minutes have passed. So our y-intercept is 0. Okay, write an equation to represent the number of revolutions y the Sky Needle rotates in x hours. Using slope-intercept form, which is y equals mx plus b, we can use the information we have and just substitute in. We know that the slope is represented by m, and the y value of the y-intercept is represented by b. So we can write the equation as y equals 1.5x plus 0. Now, just because we like to simplify everything, we're actually going to write this equation without the plus 0. Because if we added 0 to 1.5x, it would just be 1.5x. Okay, D. What does the slope represent? Since our slope is 1.5, that means the Sky Needle rotates 1.5 times every hour. E. What does the y-intercept represent? Well, our y-intercept is 0, which means there were 0 revolutions after 0 hours. Or we could say 0 revolutions at the beginning. Part F, graph and label. So if we look back at our problem, number 1, it talks about the revolutions, and it says in that second line that x represents the number of hours and y represents the number of revolutions. And that tells us how to label the axes of our graph. So the y-axis is going to be the number of revolutions, and the x-axis will be the number of hours. Okay. So now we're going to start with our y-intercept, and we're going to graph this equation. Our y-intercept is 0, so we're going to be on the y-axis at 0. So 0, 0 is our first point, meaning if there were 0 hours passed, there would be 0 revolutions. Now, we typically would go 1.5, because that's our slope, so 1.5 revolutions per hour. So we'd rise 1.5, go over 1, and that would be our next point. The issue with the graph that we're graphing on the coordinate plane is that that places us in between boxes, so not a corner of a box, which makes it harder to be accurate in the way we graph. So instead, I'm going to double that. So for every 2 hours, so I'm going to go over 2, we would rotate 3 times. And so now I can place it right there where it crosses on the coordinate plane. Then I could do it again for another 2 hours, so at 4 hours we'd have 6 revolutions since it started. And at 6 hours we would see it at 9 revolutions. Okay, and then I would take my straight edge. I don't have one for this video, but then you would draw your line through those points, and we've graphed this situation. Number 2. Savannah borrowed $1,280 to buy a new TV. She doesn't have to pay interest and pays $40 per month. Let x represent the number of months and y represent the amount Savannah still owes. A. What is the slope? Okay, to find the slope, we're looking for a rate. We know that she borrowed $1,280 to buy the new TV. And we also know that she's paying $40 per month. So we may say that the slope is 40 because it's $40 per month. That's our rate. Now, we have to be careful when we're thinking about this because what's our y-intercept, or that initial value? Well, that's the $1,280. And if we leave the slope as 40, then we're going to be thinking that we're adding 40 to this amount every time. But remember, she borrowed $1,280, and she's trying to pay it off. So she's actually decreasing that amount by $40 a month. So that means it's going to be a negative 40 for our slope. Well, now that we know our slope and our y-intercept, we can do part C, which is to write an equation to represent the amount Savannah still owes after X months. Using slope-intercept form, which is the y equals mx plus b, we can substitute in, and our equation would come out to be y equals negative 40x plus 1,280. Part D. What does the slope represent? Well, looking back at the problem, we might say, oh, and so she's paying $40 per month. But remember, it's a relationship to the debt. And so it's that the debt decreases $40 per month. Part E. What does the y-intercept represent? Well, we know that the y-intercept is $1,280 at time 0. So the debt is $1,280 at the beginning. Part F. Graph and label. So let's first label our axes. We know that the y-axis represents, right up here, the amount Savannah still owes. So the amount of debt, or we'll just put debt, okay, in dollars. And the x-axis represents the number of months. Now, before we begin plotting on this coordinate plane, we want to make sure that we understand how much each box is worth. So what's that vertical change for each of these boxes in our grid? So notice on the y-axis, that vertical axis, we're going up by increments of 80. So we have to keep that in mind as we graph and we are using the slope. Notice also that on the x-axis, we're not going by ones, right? We're going by increments of 2. And that means, so once I plot my y-intercept of 1,280, I have to go down 40 and over 1 because it's negative $40 every month. But when I go over 1 box, that's 2. So it might be easier for us to go over 2, which means we'd be decreasing by 80. So we're going to go down 1 box, over 1 box. Now, careful, that means we're decreasing by $80 for every 2 months. Then I can take a straight edge and draw our line. And your line should look something like this, which means it gets down to 0 at 32, meaning it's going to take 32 months before she's able to pay off her debt completely. Number 3, Miranda gets paid $150 per week to deliver groceries. She also earns $2 for every order she takes. Let X represent the number of orders Miranda takes in 1 week, and Y represent the amount Miranda is paid in 1 week. What is the slope? So again, we're going to look back at our problem. We're going to find the rate. It's giving us a rate, something per something else. So if we look through, we notice that she gets paid $150 per week to deliver groceries. She also earns $2 for every order she takes. Now, remember, we're doing it for 1 week. This is a key thing that we might overlook. 1 week. So since this is for 1 week, that 150 per week is not actually a rate. It's just 150. The rate comes in with a $2 for every order she takes. So our slope is going to be 2. And our y-intercept, or the y-value of our y-intercept, will be 150, because that's the constant for every week, is $150. So to write our equation, to represent the amount Miranda earns in 1 week after taking X orders, we're going to use our slope-intercept form and write it as y equals 2 times X, the number of orders, plus $150. Part D, what does the slope represent? Well, we know our slope is 2, and if we look up back to our problem, it means that $2 is earned. She's earning $2 per order taken. Okay. Part E, what does the y-intercept represent? Well, that means that she earns $150 when she takes 0 orders. Okay, so now part F, graph and label. So again, we're going to try to label first because that's helping us set up our problem, knowing how to graph it. So if we look back to this last sentence, we know that X represents the number of orders. So right down at the bottom, number of orders. And on the y-axis, we look up, it says that Y represents the amount Miranda is paid in 1 week. So we're going to put amount paid, or salary. And again, the salary is going to be in dollars, so I like to put that in parentheses just to show what we're talking about. Now that we've labeled our axes, we need to check the scale. We need to decide how much each box is worth. So how much is it going up? If you look on the y-axis, we're increasing by increments of 10. So our scale is 10. On the x-axis, our increments are by 4. So we have to keep that in consideration as we graph. So we know that at 0, which would be on the y-axis, our value would be 150. She makes $150 for 0 orders taken. As we increase the number of orders to say 4, then we could think of it as 2 times 4. 2 times 4 is 8, so we're going to add 8. But that doesn't work out very nice. Adding 8 and going over 4 gives us some point here that's just below 160, and it's going to be hard to place. So let's go up and actually use 10, or something larger that's on here, maybe 20. If you look on the x-axis, 20 is on here. You can see here. So I'm going to use 20 orders taken. So 20 times 2 is 40, and I add that to 150. So I'm going to go up 40 to 190 and over to 20. And that would be our next point. That would be easy to find. We could do it again to the 40, which means we're going to add 40 more to what we had at 190, so 230. It should also go through this point. Then take your straight edge, line up those points, and draw your line. Now again, mine won't be perfectly straight because I don't have the ability to draw a straight line on this program. But it should look something like this. Okay, number 4. Jeff put 380 M&Ms in a bowl. They are disappearing at a rate of 12 M&Ms per minute. Let X represent the number of minutes and Y the number of M&Ms in the bowl after X minutes. So what's our slope? Again, we're going to go back and look through. We got 350 M&Ms in a bowl. We also know that these M&Ms are disappearing at a rate of 12 M&Ms per minute. Now, a key there is the rate. When it says rate, oh, this has got to be my slope. There's another key here, disappearing. Think about what's happening. We have M&Ms, and they're disappearing. So that means that they're decreasing by 12 M&Ms per minute. So our slope is negative 12. Now the y-intercept, or the initial amount, would be 380 M&Ms in that bowl. So now that we have the slope and the y-intercept, we can do part C, which is to write an equation to represent the number of M&Ms in the bowl after x minutes. So we're going to start out by our slope-intercept form. Y is equal to, then we place our slope, negative 12, and x, multiplying it by the number of minutes, and then we're going to add our y-intercept, or y value of it, 380. Part D. What does the slope represent? Well, the slope represents that we're losing 12 M&Ms per minute. And what does the y-intercept represent? That means that there were 380 M&Ms in the bowl to start. Okay, now that we understand what these things are representing, let's go ahead and graph and label, which I prefer to say label then graph, this equation. So remember to label. We're going to look back at our problem above and identify these parts. So x represents the number of minutes. So along the x-axis, number of minutes. I'm going to abbreviate. And the y, we're going to do the number of M&Ms in the bowl. So number of M&Ms. And now I got to look at the scale and decide what are our increments. And I notice on the y-axis we're going up by 20s, and on the x-axis we're going up by 2s. So consider that as we graph this equation. So we can start by plotting our y-intercept at 0, 380. And next we want to be able to use our slope to help us find another point that would be easy to graph on this coordinate plane. Well, it might be a little bit difficult. So let's go ahead and think of a number that's going to make 12 come out nice and even, like 5 or 10. Because if I multiply 12 by 5, that's going to be 60, which is a nice number because it's going to be even and it'll be easy to find on our y-axis as well. So, but 5 isn't very nice to find on the x-axis, so I'm going to go over to 10. So that's right here. This value here would be 10. So if I were to place 10 in for x, I would get a negative 120. So that means I'm decreasing by 120, which would give us, if we add 380, 260. So if I place it, it would be at 10, 260 here. Then I could do the same thing. If I go over to 20, I would decrease by another 120 or 240 at this point. And that would put us at 140. And we could continue that process. Or we can take our straight edge now. So grab your straight edge, line it up with these 3 points, and go ahead and draw your line. Should look something like this. Mine got a little off there at the end, but yours should be nice and straight. Now, should I put an arrow at the end? That's always a great question to think about. We shouldn't in this case, because once we get to 0, we're done. Now, notice that this line is the x-axis, so it's got to stop. We can't go into negative number of M&Ms. This concludes the video of Lesson 2-3 of Secondary 1 Math, Writing and Graphing Linear Equations in 2 Variables.